Okay, so we're going to go over a demo now of SaaS-based recon using computer using agents and mass credential stuffing. So SaaS-based recon is quite different from the sort of port scanning of the network perimeter of old. We are principally looking at identifying applications in use, valid cloud identities, and valid tenants. So we're just going to see a quick example of this with push security ourselves as an example. Full disclosure, we are a user of Bamboo, but I'm just showing you a quick example of how this works. So we can give very basic instructions to a computer using agent, obviously operator in this case being the only one available right now, and we can see how it's able to successfully navigate to Bamboo and try valid tenant names, and we're going to see that it's identifying the login method and that the tenant is valid in this case, and we can see that there it's correctly identified that push uses Bamboo and that the login method is SSO via Google, which is correct. But really, the interesting point here is the scale. So just as another example, quickly, say Bamboo, for example, have customer success stories. These are some of the customers on their website. I told it to go away and look for examples of other customers and then try their tenant names and try to identify their login methods too. And as a result, we get something that looks like this. So we can see it's been able to start scaling this across different customers, and it's come back and identified a range of valid tenants and the different types of login methods that it observed was configured, which is really powerful when it's able to do this automatically with very basic instructions. So the important point with this is really not doing it for any one app. It's not that difficult to do this on your own, even without automation. The important point is that it's able to do this generically based on simple instructions for any application. So the real use here is scaling this across 1,000 apps or 10,000 apps. So it would be like saying, which apps to push security use and what do they use to log into them on 10,000 apps, and then identifying the complete identity infrastructure from that. That's where the real game-changing capability is. So moving on, the really dangerous component is when we get to credential stuffing. So let's consider a scenario where we've stolen some credentials from an info stealer, or we've done some credential harvesting for phishing. I want to say, let's say we've mapped out a bit of identity attack surface. For simplicity, I'm just going to use a few different apps here, and I'm going to say, can you please try and log in with these credentials that I think might be valid in some places? Again, very basic instructions we've given it, and we can see that it's able to start browsing and doing this without any additional specific instructions for the application in question. So first of all, it's trying Microsoft, and it's going to enter the email address, enter the password we've given it, and after that, it's going to find that in this case, this is quite a well-protected Microsoft account. I've configured it with a security key for MFA, and so it's just going to identify that that was the case, make a note of it, and move on. The second app in our list is Atlassian, so we're going to see it now try to go through the Atlassian login method. So in this case, it's able to enter an email address, click continue, and Atlassian is going to indicate that that account's been used before, but it's linked to a Google account. So again, it's not able to enter credentials, but it's going to observe that it's tied to a Google account in this case for a social-based login. We'll then move on to finding Shortcut, which is the third app on our list. If you're not familiar with Shortcut, it's a little bit like Jira. It's another sort of story and ticket management system. And we'll see that it's been able to find Shortcut. It's going to go to the login page. It's going to enter the credentials. And then we're going to see that in this case, the credentials themselves work. And it's able to successfully access Shortcut. So we're just skipping ahead. We won't do the final two, but just looking at the results in the end, it's been able to correctly summarize the results that have been seen. So we've seen that Microsoft password was accepted, but it prompted for a security key. Atlassian, the account was valid, but Google login was required. And then for Shortcut and Euclino, the password is accepted and it logged in successfully, single factor. And for Dropbox, it identified that the email was not recognized, and so it was unable to test the password, but also that obviously means that that account is not a user for Dropbox. So we're just showing this with 5 apps here, but the real scale is being able to do this for 1,000 or 10,000. So imagine you could orchestrate 1,000 computer user agents to do this in parallel against 1,000 or 10,000 apps and identify where the credentials are valid. This is really going to 10 times or even 100 times credential stuffing in the SaaS-based world.